Hey, Algebra 1, we are going to be working on Chapter 2, equations, linear equations, and we're going to talk about percent of change. Our vocabulary is as follows: percent of change, percent of increase, and percent decrease. I think the best way to look at these vocabulary words, I'll give you definitions, but is to kind of look at a quick example. So here's a bit of something that I like to do. I like to watch Biggest Loser. And I'm always amazed at the change that these contestants go through. And in this case, we've got a gentleman who has gone from 287 pounds down to 163 with a difference of 124 pounds. So when you notice that they compare who wins, they don't just compare how much weight somebody lost, they do it by percentage. Because let's say a guy that was 500 pounds lost 163 pounds, that would be, or lost 124 pounds, that would be good, but he wouldn't be the winner because they compare it by percent of weight loss. They compare percent weight loss. So what we're going to do is we're going to figure out the percent. And to figure out this percent change, we take the change, the difference that is, so in this case it's 124, and we compare it to the original, which is 287. Then we calculate what that percentage would be. And we remember when we calculate percentage, we're basically looking for how much out of 100%. So we compare the original to 100%, and then we calculate this x value. We are really good at calculating proportions and solving proportion problems because we know we got the power to cross multiply. So when I do that, sorry Dan for writing over you, we get 287x is equal to 12,400. Quick division here, if we divide both sides by 287, what we'll get is that Dan lost 43.2% of his body weight. Pretty good job. Now here's the thing. This is considered a loss. And because this is a loss, this is actually considered percent decrease. Or sometimes I put a negative sign. Or we can talk sometimes about percent increase, an arrow up, or a positive sign. And those are the three words that we're going to talk about today. Percent change, percent of increase, and percent of decrease. So let's get back to the vocabulary. Percent of change is really just that ratio, is just the ratio of change to the original amount that's going to be expressed as a percent, just like we did with Dan's weight. And the other one, the percent of increase, is really if this percent change happens to be an increase or a positive increasing amount. Or if the percent decrease, as in Dan, if it's a percent decrease, as it was in Dan's case, we're going to see loss, and the percentage would refer to the amount of something that's lost. I should say lost or reduced. There we go. Okay, let's take a look at this first example here. We have an original amount of 20 and a final amount of 23. First thing we need to do is figure out the change. The change is 3. So I'm going to compare the change of 3 to the original, which is 20. Here's the ratio. Let's calculate what percentage this is. To do that, I need to put x over 100 because I'm going to compare this amount as this amount would appear to 100. So as 3 compares to 20, I'm going to compare that x to 100, and that x would be my percentage. When I cross multiply, I get that 300 is equal to 20x, and with a little bit of division, I can see that x is equal to 15. Since this is an increase from 20 to 23, this would be considered 15% increase. For this next one, the change is 8. You can already see that this is a decrease. I'm going to put 8 here and divide it by the original amount. I think I need a new color here. I'm going to run into some problems. So I have 8 over 25, and I'm going to set that equal to x over 100. Again, comparing it to 100. When I do that, I get 25x is equal to 800, and with a little bit more work, I see that x is equal to 32%. This percentage would be a percent decrease. Let's try another. In this example, we're given the percent change, but there's some information that's missing, particularly the original. So let's take a look and let's see if we can figure out what's going on. We see that the amount of cruise ships in North America increased by this 18% from this time, 2000 to 2005. But in 2005, we're given that there were 192 ships. The question is, how many ships did we have in the year 2000? So we have some information. We know that the original amount, well, we're not quite sure what the original is, and when we're not quite sure in algebra, we put an X. And what we do know what the final amount is, or the final as of 2005, the final was 192. So we're going to set up the equation like we're used to. We're going to put X as the original, because that's what we always compare it to. We'll put 18 here, because we are given the percent change over 100. And over in the numerator, the change is going to be 192 minus X, because if I take the final amount and subtract the original amount, that'll be the change. So now I have this problem, this proportion that I know how to solve. I'm going to cross multiply and proceed as usual. First, I have 18x is equal to 100 times the quantity of 192 minus x. Those parentheses are necessary. Now I'm going to do my distributive property and get 19,200 minus 100x. And then I'm going to do a little bit of solving. Adding 100x to both sides leaves me with 118x is equal to 19,200. And with a little bit of division, I'm going to get that my answer will be, let's see, 118x is equal to 162.7. And I'm going to just round it down to 162 as the answer, because that's whole ships. So 162 ships approximately, maybe even 163, but 162 ships is what we're going to go for that we had in the year 2000. Okay, so Marta is purchasing supplies to make beaded jewelry. If her supplies come to $28.62 before tax, and tax is $7.25%, what is the final cost? So we do need to figure out what the percentage amount is, or what the tax that's being added on. And to do that, I'm going to just put a little T here and say that the tax, or I'm going to put the word tax. Tax will be calculated like this. The tax is based on the amount that her items came to, so that's $28.62. We're going to treat that as if that's 100%, and we want 7.25% of that. If you calculate this, cross multiply, solve for tax, do what you need to do, you're going to get the tax amount. Here is a way to get the answer straight off, because we don't want to know just what the taxes come to, we want to know the final cost. So what you could do is, I'm going to put F here for final cost. Again, you're comparing the amount that we're going to get to $28.62, but I want not only 7.25%, but I also want 100% added on to the 7.25%. The reason why is I want to automatically add in the original cost before taxes, so I can get my answer in one fell swoop. When I calculate the first one, I get $2.07, and of course I'm going to have to take that amount and add it back onto the original. But when I calculate this one, when I get the final cost, I get my answer in one fell swoop without actually adding. I get $30.69. Okay, friends, I think that's enough examples for us, and here is our assignment. Do make sure you bring any questions to class and take it easy.